Hi, my name is Harni Balasubramaniam. I'm from New Hyde Park, New York. I'm currently in 11th grade at New Hyde Park Memorial High School. The title of my research is PROTAC-mediated chromosomal degradation of homology 2 domain containing phosphate 2 for solid tumor therapy. Unlike liquid tumors such as leukemia, solid tumors form as abnormal tissue masses, which make them much harder to treat effectively. Key player in this cancer cell growth is a protein called SHP2, encoded by the PTPN11 gene. So instead of trying to block SHP2 activity temporarily, my research focused on something more permanent, completely degrading the protein itself using a technology called PROTACs, or proteolase targeting chimeras. PROTACs are small molecules designed to bring two proteins together: target protein, which is SHP2, and E3 ligase, which is the good protein, so that the target gets tagged for destruction by the cell's natural waste system, the proteasome. In my project, I used IFoRE to predict 3D structures of SHP2, and I modeled my PROTAC candidates using the IFoRE software. Then I performed molecular docking simulations with HDOC to see how strongly these PROTACs could bind as both SHP2 and E3 ligase proteins. To prove binding even further, I used CREM web server to generate chemically reasonable mutations, essentially creating a library of PROTAC variants. For each variant, I used PLIT to identify important hydrophobic interactions and hydrogen bonds, and Prodigy to calculate the binding free energy. One particular PROTAC, which I called P1 mutant, showed the strongest binding energy at negative 10.02 kilocalorie per mole, making it a promising candidate for further testing. However, one of my limitations I encountered is that it's entirely computational, meaning all the results are based on simulations rather than real lab experiments. Therefore, the findings need to be experimentally validated in cell and animal models to confirm their biological relevance and therapeutic potential. Overall, by improving their binding affinity and pharmacological properties, this approach could one day lead to more effective and targeted treatments for solid tumors with fewer side effects than traditional chemotherapy. Thank you so much for listening.